Good afternoon and welcome. This afternoon session, data modeling and reporting for the business user with Excel and SharePoint. Okay, my name is Peter Myers. A very brief introduction. I consider myself to be a BI expert, having worked in this space for well over a decade. Coming from a business background and learning how to solve data-related problems after my economics degree has been very, very handy in my career in solving data-related challenges. 15 years experience all up working with the Microsoft stack of database products, development products. And my accent may give me away a little bit. I actually come from Melbourne, Australia, although I was recently living here in San Francisco for about 4 years. I've been recognized for my community contributions as a presenter. So Microsoft for the last 6 years have awarded me Most Valued Professional status. And on a good day, this is what I look like, for those that are watching this in recording. Should there be a need to contact me in relation to any of this contact, you may find me floating around this conference center, but I think as you'll have discovered, it's like finding a needle in a haystack. It's totally huge here. So you can reach out to me either by email address or through LinkedIn here. The objectives for this session then is to inspire you with the potential of self-service business intelligence and how this can be achieved with the new capabilities delivered in Excel 2013 in the client. And when we publish those workbooks to SharePoint, we'll also explore the capabilities we have for self-managed BI. So this session will be useful for those that are new to Power Pivot and Power View. For those that already have some experience with both or either of these, what will be of interest to you in this session will be the highlights of what is new in this release. So I will be focusing on the new features and capabilities delivered inside Power Pivot and Power View with Excel 2013. So the outline we'll start with the Excel client. We'll then take a look at what it takes to create a workbook data model and then to build reports based on that model. And finally, we'll wrap up with considerations for upgrade and a summary of what's been covered here with resources. Okay, so let's start with the Excel 2013 client, starting with an introduction of Power Pivot. Just out of interest here in the audience, by show of hand, who is already working with Power Pivot? So it's about half of you. So that's a really good indication of being in the right room at the right time. Don't be afraid that I'm introducing what Power Pivot is here. We will be exploring its capabilities, but also what's new. So it goes from strength to strength in the Excel 2013 release by delivering advanced data modeling and rich interactive reporting capabilities within the client itself. So within a single workbook, a data model can be developed. You can integrate data from multiple data sources, potentially different data formats. We can then enrich this data model with hierarchies, calculations, and key performance indicators to support monitoring of our data. Within the very same workbook, reports can be based on the workbook data model. And so in addition to the old favorites of pivot tables, pivot charts, and the cube functions, and I have to ask the audience, again by show of hands, who works with the cube functions when it comes to producing reports based off data models? So of interest there, I probably had maybe 2/3 of the audience express that they've worked with Power Pivot before, but perhaps 20% of the audience were even aware or familiar with using the cube functions. They're one of my favorite approaches to building customized reports inside Excel. And we'll be able to provide you a little bit of insight with these today in the demonstration. So with the old favorites of pivot tables, pivot charts, cube functions, the new one on the block is that we now have Power View, the ability to insert Power View sheets into the workbook itself. And what I particularly like about this is that a single document, this XLSX document that is portable, can contain both your data model in definition and data, and then you can have accompanying reports, and now richer interactive reports beyond what a pivot table could deliver with a Power View sheet. The workbook can then be published to SharePoint, and then we have a self-managed environment. The analyst that created the workbook could go ahead and secure that document to ensure only the right people have right access to it. In addition, they could ensure the data is kept up to date by scheduling automatic data refresh for particular connections. There's also this scenario with Office 365. We can publish an XLSX that contains a workbook data model and reports up there into Office 365 and have similar capabilities, but no auto data refresh. A focus on Power Pivot then, it extends Excel's native capabilities to manage compressed storage of and extremely fast querying and reporting from tabular data. And it achieves this with the X-Velocity in-memory engine. Essentially what happens when you import data is the data is imported, it is compressed and optimized for querying, and this engine is responsible for this. So in essence, it supports developing a data model within the Excel client itself. The highlights are that you can load data from a variety of data sources, extremely large volumes of data can be stored, and I've seen examples of literally millions, hundreds of millions of rows being compressed and stored efficiently inside a single Excel workbook. To enrich the data model, there's an expression language named Data Analysis Expressions, often referred to as its acronym of DAX, that allows you to enrich the model with calculated columns and measures. The model then can be enriched with hierarchies to support navigation, drilling down, drilling up, key performance indicators, perspectives, and reporting metadata, which we'll cover in this session as an optimization in order to exploit the unique capabilities of Power View. So be aware that Power Pivot was first introduced as an add-in for SQL Server 2008 R2, providing you had Excel 2010. This was a free download to extend the capabilities of Excel. Be aware in Excel 2013 in the client, this add-in is automatically installed, but by default is not enabled, as I'll demonstrate shortly. Power View then was made available in the last release of SQL Server 2012, providing you have SharePoint Server 2010 in Enterprise, and you've installed the Reporting Services add-in, and then on the client you had Silverlight 5, then users could start to produce their own reports in the browser based on a tabular model. That tabular model could either be a Power Pivot workbook that had been published to SharePoint, or it could be a tabular database that was on a standalone instance of analysis services somewhere on the network. So Power View is about producing presentation-ready, rich, interactive reports. I liked one of the objectives that the product team was given, and it was that design features should be accessible with minimal clicks. And I think as you start to work with Power View, you begin to appreciate just how powerful this product is at quickly producing very good-looking reports. So be aware that in the Excel 2013 client, it is an add-in that's installed automatically. It is not enabled by default. You might wonder, why is it installed but not enabled? By default, we may discover that the majority of users in Excel won't be using these tools. There is a price to pay for having them enabled, in that the startup of Excel will be slowed down by loading these add-ins. So by default, they're not enabled. To enable them, you can explicitly do so by going to the options for Excel, or in fact, the first time you go to insert a Power View sheet, if it's not enabled, it will simply say, it's not enabled, would you like to enable it now? And it's as simple as that to enable the add-in. Be aware that Silverlight 5 must be installed on the clients to work with Power View. So this is very much the development workflow, when producing a data model inside the Excel workbook. You will import data to create tables. You will then enrich the data model by establishing relationships where appropriate between the tables that you've imported. You can then enrich it further with calculated columns, measures, KPIs, hierarchies, and perspectives, and I will demonstrate all of these in this session. If your intention is to use Power View, by default, that model may be sufficient, but if you're wanting to work with some of the great capabilities in Power View, like images, there's additional work that you'll likely need to do to surface those images through Power View. So I'll be covering the optimization of a model in this session also. Next, you'll go ahead and produce reports based on the data model, whether they're Power View sheets, pivot tables, pivot charts, or a custom layout by using those cube functions. And then finally, and what I would mark as optionally, if you needed to share this data model and its associated reports, you can publish that workbook to a library in SharePoint, providing that the Power Pivot add-in is installed and activated. Then you'll have the capabilities there in the browser and accessible to a wider audience than would be just on your client. So describing the audiences that could be involved with this product, Excel users will go ahead and produce workbooks that will consist of data models and reports. And I'd like to pause at this moment and really think about who these Excel users are. Now, being perhaps, or probably, the world's most popular spreadsheeting application, we're likely to find Excel is installed on numerous desktops, but I would argue that the vast majority of people that have Excel are unlikely to need Power Pivot. My test as a consultant, when I go into my customer to see whether Power Pivot is a fit for their needs, is to actually ask whether they've worked with the VLOOKUP function before. And if anyone in Excel is familiar with the VLOOKUP function, they'll understand that that allows integrating data from different sets or ranges within the workbook. Now, if you've needed that function before, it's likely that Power Pivot is going to become your closest friend. The fact is it will do it far more simply and efficiently, and you no longer need to manually build formula to start integrating data. Just relate the two tables together on a common column. The other consideration would be volumes of data, because an Excel worksheet has a limitation of the number of rows in a worksheet. So therefore, if you're loading data in from an external source and you exceed the number of rows, and can anyone tell me the maximum number of rows in a sheet? Supported or unsupported? Supported. You can't exceed this. Any guesses? 50? Probably a little more. 100? It's actually 2 to the power of 20, and if I was going to compute that, it's just over 1 million. And I can tell you that 10 years ago, even 5 years ago, that would have been more than sufficient for the data challenges I had in those days. But by today's standards, 1 million rows is not a lot of data. So for those users that need to work with large volumes of data, Power Pivot is also going to help them, because when you load the data, it doesn't load it into a worksheet, it loads it into the workbook model. So you're only limited then by resources or ultimately what will become the document size itself. Now be aware the intention is to publish the Excel workbook to a SharePoint library. We do have a constraint for the document size, which says it should not exceed 2 gigabytes. All right? Now let me tell you that 2 gigabytes is an awful lot when it comes to efficiently compressed data. So if I found that I had a business analyst working with that type of data, it probably would convince me very quickly that this is a project that should be managed by the IT professionals and developers, and this should become a fully fledged tabular database rather than a Power Pivot data model. Okay, so those Excel users, I like to actually call analysts, maybe your business analysts, maybe even your power users. They'll produce workbook data models and reports. They will potentially publish and secure these in SharePoint. They will configure automatic data refresh to ensure the data is kept current within the model. And they may create new analytic and reporting experiences by connecting to that workbook. Because the wonderful story is that the URL to that workbook can be used in a connection string by other reporting experiences, like reporting services, other Power Pivot workbooks, performance point services, to go ahead and connect to and consume the data in that published workbook. For the IT professionals, they will be responsible for installing and configuring the server environment, managing the Power Pivot service application, and monitoring workbook usage and resource utilization. This is where there is some management ability from IT to actually keep track on what workbooks are being published, how they're being used, what resources they are taking up. Finally, for the information workers, those general users, they can browse to the libraries and interact with the published workbooks and the reports contained therein. So, next section is creating a workbook data model. So what is new with Power Pivot in Excel 2013 is there's actually two approaches that I have called the implicit and explicit approaches to creating a workbook data model. Implicit data models are based on internal workbook tables and or external data sources. The reason I call it implicit is even if the Power Pivot add-in is not enabled, they won't see the Power Pivot tab on the ribbon, but they can leverage that X-Velocity in-memory analytics engine. They can load in volumes of data that exceed the number of rows in a worksheet. They can go ahead and manage relationships between multiple data sources, and they can create basic measures. So in a sense, they are using the capabilities to build a data model, but unbeknown to them, they're using native Excel capabilities. But under the covers, it is using the technology that Power Pivot uses. To have complete control over this process, an explicit data model should be created. You'll need to have the add-in enabled to support this, and then you'll go ahead and open up the Power Pivot window, and within this window you have a complete environment for importing data, relating data, and enriching the data model. So let me show you by the first demonstration. I launch Excel, and the first thing you may notice when I create a new blank worksheet or workbook is there is no Power Pivot tab. And that doesn't put me off at this stage. And I'll point out to you here on Files under Options, if we take a look at the add-ins, that indeed, as I explained, the add-ins for Power Pivot and Power View are installed but not enabled by default. And I'll leave them off for now. If I come to the Data tab, and then I bring in data from SQL Server, connect to my local instance, and I have a database here for Tailspin Toys. This represents a toy retailer of model aeroplanes and helicopters. What is new is that we have this option to enable multi-table selection. And I could come in here and select sales. I could then introduce related tables according to the foreign keys that are defined in the data source itself. And note the option here that is turned on that will import those foreign key relationships as relationships into some data model. Click Next. We're back to the familiar how we define the Office data connection file, so I'll leave the defaults here. Click Finish. And then we'll see that we can create a pivot table based off what's created. Now, this checkbox down here at the bottom of this window is actually disabled. The fact is, if you import multiple tables at the same time, it must create an implicit data model for you. If I selected a single table, then the option would be there to add that to the workbook data model. Clicking OK, watch the status down here, retrieving data. And here it is loading about 3.25 million rows of sales data and related information from the state product tables. So this is the creation of an implicit data model. And while it's doing that, in fact, I have to wait for it to finish. Before I move ahead with the pivot table, if I come to the connections, what we now see is there, as the first in the connection list, is that connection to the multiple tables that I selected. You can come in here to the properties, and you can modify the definition. You could increase the comma-separated list here of the tables that would be imported. They're part of the ODC, the Office Data Connection file. This one here represents the connection to the workbook data model. If you're familiar with Power Pivot in the previous releases, you'll note that it has changed its name. It used to be the Power Pivot model, I think. I've now forgotten. What is different also is the properties are disabled. You can no longer modify the properties on how an internal connection is made to the workbook data model. You can't delete it either. That's a good thing. So back on track here, we see that I have a pivot table here in cell A1. And this is now connecting to that workbook data model. And I can come in here and say, well, show me by category what the sales were. So I have a revenue field. And here it is on the fly, aggregating 3.25 million rows of data to show me that this is what revenue looked like. Now, one very cool new feature that I can show off at this stage, because I have a date field in the sales table. Now, be aware that this is truly a date value, not an integer based on a date. I can right-click and I can say Add a timeline. And a timeline allows you for calendar periods to filter at different granularities. For example, let's have a look at 2011 only, or maybe at quarter level, I'd like to look at the last 2 quarters of 2011. So this is very, very cool if you don't want to go to the trouble of building an explicit date table that has columns of year, quarter, month. Is that now just by having a date column with date values, you can analyze using time. There are some limitations. It's calendar period only, and when you're working with ranges, they must be contiguous ranges. I can't say, give me quarter 1 and quarter 3. I'd have to say from quarter 1 to quarter 3. Next, when it comes to the slices, if you were familiar with the Power Pivot field list, you'll then think, hold on, we're missing 2 of the drop zones. We used to have vertical and horizontal slices. Now, you haven't lost the functionality. What you need to do is right-click a field and then add as a slicer. So now we can come in here and say, well, what were the sales just for the state that we're in? I'm not sure that Nevada has any. Yes, we do. And then we can go ahead and slice. So this is what I refer to as an implicit data model. If you have other data connections, then you have the ability to add them individually to that workbook data model. And then on the data ribbon, you have the ability to manage relationships. So the fact is, an implicit data model is very, very powerful using the native Excel functionality. Import data, relate it. And what may not be evident is that when I added the revenue field to the values drop zone, that created what we refer to as an implicit measure, a calculation in the model itself. So at this stage, if I go ahead and turn on that add-in for Power Pivot, there's nothing to stop you coming in here and then managing the data model that was implicitly created. And here it is. For my sales table, there's the 3.274 million rows of data. We switch across to diagram view, we see the relationships that were imported at the same time as creating the tables. And then on the advanced tab, we don't often do this, but if we say show implicit calculated fields, there is the measure that was created simply by dropping a numeric field into the values drop zone. All right, so even if we don't intend to work with Power Pivot, it's there in the background. And we can benefit from the ability to work with larger volumes of data. The explicit approach, as I've just shown you, involves opening up the Power Pivot window and working natively with the functionality on the ribbon of that window. It can, as I've just demonstrated, be based on an already created implicit data model. So new features, if we take a look at settings. In the settings window, there's now support for an additional 20 languages. So all up, 43 languages are supported by this product. In addition, configuration of categorization options, and let me show you by demonstration. So here on the Power Pivot tab, coming to settings, this is where you'll find the new languages. But this tab here for categorization has 3 options that you can turn on or off. Detect data categorization automatically. So when table data is being imported, it will look at the data itself and potentially categorize it correctly. Why would this be useful? Well, categorization of data could be an optimization for a tool like PowerView. Is this a geographic column, and therefore would mapping and geographic representation benefit from it? So think of categorization like a type that is applied to the column that provides extra information about what the model means. Now, when you have that meaning built in, there is the ability to say, well, when you're looking for suggested data, which is a new feature in the product, it will use those categorizations to look for related data sets out there in the Azure Marketplace to find potential data that could enrich your model even further. Finally, because the algorithms that detect the categorization could change over time, there is this default that's turned on that says that it will download automatically updates to help it better find and categorize data. The Power Pivot window itself. So when I just demonstrated this, you may have noticed that the Advanced tab was on. The Advanced tab was introduced in the last release with SQL Server 2012 and the add-in there for Excel 2010. And the Advanced tab was actually hidden by default. You had to turn it on to get the functionality, like perspectives and the reporting properties. I think they discovered that confused more people than they thought. So the fact is, by default, it's on. You can turn the Advanced tab off if you need to. Inside the Home ribbon tabs, Get External Data Group, and in relation to the categorization that I've just introduced, you have the ability then to look for suggested related data. Now, if that option, which is not on by default, to go ahead and use categorization to look for suggested data sets, the first attempt to use this new feature to suggest related data will prompt you to turn it on. Next, existing connections has always been there, but it was found on the Design tab. And I discovered that beginners, in particular, If they were importing data from the same data source, they would often go ahead and redefine an entirely new data source by importing the data from SQL Server, for example, instead of going to the existing connections and opening an existing connection and importing from it. So I'm happy to see that they're all kept together now. Do I define a new connection, or do I base this import off an existing connection in my data model? The pivot table command now includes PowerView. Actually, that's wrong. It did in the preview, but in the final release, it's been dropped. Unfortunately, this slide deck was submitted before I saw the final release. So scratch this. You will not see PowerView down there. In order to insert a PowerView sheet, you'll need to be in the Excel window, and you'll use the Insert ribbon, and then you'll find PowerView is there, as I'll demonstrate shortly. There is a find functionality. So when you're looking for a column or a table or a calculated field, you can just find it by text. And there's the option to also search through hidden objects, which by default it will not do. Inside the Advanced tab, you have the ability to create and manage perspectives. That's not new, but what is new is the ability to select a perspective and thereby filter down what you see in the Power Pivot window. What is different in this release is that in the previous release, when perspectives were introduced, it was only in diagram view that would limit according to what your perspective shows. So to be absolutely clear, a perspective is a means of narrowing down the visibility of the resources in a model. It's usually used when you have multiple subject areas in a single data model, and you don't want to confuse your business user. If I've got a finance-related question, I would use the finance perspective, and I would only look at the tables and calculated fields that have some financial relevance. So what is new now is that when you filter by a perspective in grid view, it will also hide columns and calculated fields and tables that do not belong to that perspective. On the far right, you will see the data category. And this is where, upon the selection of a column, you can categorize what that column is storing. If, and by default, that auto-categorization is turned on, that when you import data, it will auto-categorize using some internal technology. Doesn't always get it right, but it's usually reliable when it does. Otherwise, you will just change the categorization yourself. Be aware that what is missing, we used to have a checkbox that said, this is an image URL. In other words, the content of this text column contains a reference to an external image that PowerView then could represent. That is now gone. You will use the categorization for that column that it is a web URL. All right, we will come back to workbook reports. It's time to create a data model explicitly. Before I do, I'm going to go ahead and save this workbook. And I'd like to make it absolutely clear that when I save it, it's really doing a backup of your data model, its metadata, the data that has been loaded, and it's storing that backup inside the XLSX. So now when I come back and look at this file, we can appreciate that the document size is actually 51.1 megabytes. Does that seem large for 3.25 million rows of data? Anyone? No? Okay. Close. So where I head to in this next demonstration is to create an entirely new workbook explicitly by using the Power Pivot window. So the challenges that I have here at Tailspin Toys is that we have a database that stores sales information, but the analysis that I need to do involves profit calculation. And the sales system doesn't store the cost of the products that we sell. And this is a classic example of where Power Pivot can come in and solve a problem that the corporate systems don't. We can source the sales information, and then in a workbook, I have per product the cost to produce those. And then I can introduce this data, relate it, and then start to produce calculations of profit. So my starting point is here in the Power Pivot window from database, and these are the Microsoft database products. From SQL Server, I'll go ahead and define a connection to the Tailspin Toys database. When you import from a relational database, you have a choice to import from a list of tables and views or to write a query that will be imported as a single table. My first pass will be to just introduce the sales and those related tables. Now, it picks up state. I'm going to remove it, and I'll explain why in the next part of the demonstration. But once you've made your selection of tables, the next thing is to come in here and preview and filter and limit the amount of data that will be loaded into your data model. Now, this technology, tabular development with this X-velocity in-memory engine, if there is an important optimization to take on board, it's that you should not introduce data that is just not relevant. Because of this in-memory capability, you don't want to introduce data that is going to then occupy or use memory that could otherwise be used by other processes. So I come in here, and there's two ways for relational data to filter. I really like this checkbox in the top left corner because it actually removes all checks, and it makes me explicitly introduce what I need for this model. The fact is, I do need almost all of them. There are calculations down here for retail price and wholesale price. They're not relevant, so I simply remove them. That's what I refer to as vertical filtering by removing columns. You can also horizontally filter by applying filters at column level. Next, I come to the sales table, preview and filter here, and I look at the first column and I say, well, look, the order number, it's useful to actually link back to the source system, but for the analysis that I need to do, I'm not going to include it. So be aware that the implicit data model that I created first off in this session, you have no capability to filter vertically or horizontally. You have to accept the entire table. Whereas here, I can optimize the model by removing columns. So I have this date column, the state key, product key, the quantity, and the revenue for that sale. I click Finish. That completes the table import wizard. It thereby creates two tables, and it imports the data. And we can see the status here as it's loading in those 3.274 million rows of data. In addition, the details here confirm that the relationship between product and sales has been detected and automatically created. Now, when it comes to bringing state data in, the reason that I didn't import it at the same time is that I also have a related table to state, which is region. This is demonstrating the new existing connections. Just open up the connection that I have to Tailspin Toys, which relaunches the table import wizard, and this time I'm going to write a query that brings in a result that joins the two tables together. Up here, the friendly name will become the name of the table in my data model. Click Design, and what we see here is the Relational Query Designer. If you're familiar with Report Builder, it's exactly the same experience for building up a relational query. So I can come in here and select the state ID required for the relationship to the sales table, the state code, the state, and then I'll bring in the region. I can test the query, and it copies in the required select statement. Be aware, if you have a stored procedure that returns a single result set and you don't turn set no count on, then you could also execute a stored procedure here to introduce data to create a table. And now in my model, I have three tables: product, sales, and the new state. But because I've imported them in separate processes, I like to do this in diagram view, I would be required to manually create that relationship. Only if they're imported at the same time would those relationships be detected and created. Next, very important for date analysis that we have a date table. With the exception of that new capability that I demonstrated with the timeline, we're providing that it's a calendar period from January to December, and that you have regular periods like year, quarter, month. Then you can work with that type of feature, but that won't work in PowerView. And just having a single date column is somewhat cumbersome. So in this organization, the IT professionals have supported the Power Pivot users by exposing a data feed that delivers relevant information to support Power Pivot data modeling. So what we find from this data service, and I copy the URL, is that there are two data feeds, one that delivers corporate date information and another that delivers corporate time. So switching back to the Power Pivot window, I can go ahead and say, this time, let's bring in data from an OData feed. So this happens to be an intranet, but this is the way that you might actually import data from an external feed out there on the web. So it interrogates the service and discovers that there are two feeds. I'm going to provide a friendly name that will result in the name of the table in this data model. Corporate date becomes simply date. The preview and filter, so be aware for data feeds, you cannot horizontally filter. The best you can do is vertically filter by removing certain columns. I'll need the date to join to the sales table. I have a date label, I have a month key, and I have a month label. Look at the pattern here that the month key is really the year multiplied by 100 plus the month number of year. The reason that this is important is if you want to sort your months chronologically as opposed to the default of alphabetically, you'll need to have a column like this in the table. And this is why the feed is very handy. It's already been produced to support that capability. I need calendar quarter label, and I also need calendar year label. If I had time, I might also bring in fiscal periods, but I don't. So I click Finish, and there's the introduction of a fourth table into the data model. This so happens to come from a completely different data format. We relate date to date. Lastly, in order to compute profit, I need to bring in the product cost data. And in this environment, what I've done is created an Excel workbook and saved it as a CSV file. So in this share, we'll see that I have a CSV file named product cost. It's important that this is in a share because if I intend to publish this workbook to SharePoint and configure automatic data refresh, I don't want it to say C drive because from the SharePoint farm perspective, that C drive is going to mean something completely different. So the share is the appropriate way to store this data. I can then come back to the Power Pivot window from other data sources this time. I'm not quite sure why it's having a good think about that. Right down the bottom of the list, we have the ability to bring in data from a text file. So this time, I paste in the path to the CSV. The CSV consists of the stock keeping unit, the product name, and the cost to produce it. I don't need the product name. Again, this optimization, the product name is already in the product table, but I do need the stock keeping unit to create a relationship between my product table to introduce the related cost. Click Finish, and now my model consists of 5 tables, 3 of which come from a relational store, 1 of which is a data feed, 1 of which is a CSV file. And I can strike the relationship from stock keeping unit to stock keeping unit. So how simple it is to introduce different data formats and simply relate them now that they're in tabular form. I'm just going to save this workbook in case anything happens. This will be my explicit sales analysis. And then I'll continue on with the development. So once you've introduced the data and established the relationships, the next phase is to enrich the data model for usability purpose. So table by table, it's a matter of then enriching and optimizing. So when I right-click and I go to the date table, this is what the data looks like in tabular format. The first optimization here on the Design tab is to mark this as a date table. So this pretty much updates the metadata to say that this is where date is defined, and we must specify a column that contains date data. And by date, I mean it must be of type date. And there's another rule. There must be no gaps in your date table. If you do not configure this, then the DAX time intelligence functions will not work, like year to date and so on. With that configured, the next thing I'll do is perhaps rename the columns so they make more sense to anyone that is consuming my data model. Now, when we look at the content of month, if I attempt to filter it, we get to see the distinct values here, and immediately we understand that there's a problem. Here is where we're seeing the default sort order is just alphabetic. And yet if my intention is to have these chronologically sequenced, then what I can do for this column on the home ribbon is to sort it by another column. Now, providing that the column is in the same table and there is truly a one-to-one relationship between the values in both columns, and this is how you influence sort order. January, February, March. So the next optimization would be to go ahead and hide columns that you don't want users to see. So all that is visible for this table will be day, month, quarter, and year. To support the browsing and navigation, what we'll next introduce is a hierarchy. So hierarchies can only be defined in diagram view. And so back in diagram view, I can maximize this table just to make things easier. And the multi-selection of those columns and then the selection of those allows me to create a hierarchy on those columns, and the hierarchy will be based, or the levels of the hierarchy will be based on those columns. And you may well ask, how does it know that the order is actually year, quarter, month, day? And the fact is, it does look at the data and the relationships between the values in those columns. So usually, providing you have sufficient volumes, it will sequence the levels correctly. If not, it's just a matter of drag and dropping to resequence, or you can manually add the levels one by one to a hierarchy. The next optimization then may be to go ahead and hide these columns so that this table only exposes a visible hierarchy consisting of these 4 levels. Next, we'll have a look at state. This is pretty straightforward. I'll just create the states hierarchy, and then I'll hide these columns. Now, of interest to note that when I select the state column and look on the Advanced tab, look at the data categorization. It knows that this is a state or province. That's the auto detection coming in. For product, I'll create a hierarchy from category to product. And then I'll hide the numeric key. So next, focusing on sales itself. What's unique about this table in the design is that it has these numeric columns that is really containing the values that we want to aggregate for the purpose of reporting. The other tables are what we'd typically call, in a star schema anyway, dimension tables. They describe the business entities of product, geographic region, and time. So switching across to the sales table. I see that I have quantity, I have revenue, and yet I need to introduce cost here. So by defining a calculated column that is equal to related, and this is how we traverse the relationships from the many to the one side, let's introduce from the product cost table the related cost. So what's interesting to note here is that when you look at the relationships from the sales table, it's navigating using this relationship to the product that in turn is navigating to here to look up the cost to create this new column. I multiply by quantity, and now I have a column that represents the cost of goods sold. And I could choose then to come to the home and format this as currency. And there we go. Now, the fact is, there's another type of calculation that is defined down here in the calculation area. DAX can be used to extend the tabular definition with new columns, as I've just demonstrated. DAX can also be used to define measures that are typically used for the aggregation of values found in columns. So the fast way to create these is to multi-select columns, use the auto sum here, and say, let's create the sum measures based on those columns. And we see 3 calculations added to the calculation area. Now, in DAX, the way that it's done is that the first part is the name of the calculated field, colon equals the DAX function, that in this case is sum of quantity. And so there's the units, and I can go ahead and format this as a whole number and comma separate. Now, I think there's some bug going on here because typically what you see is the result sitting in the calculation area. For some reason, it's just disappeared on me. I have discovered that if you close the workbook and reopen it, they come back. So apologies that they're not showing at this stage. For revenue, I'm going to go ahead and name this simply sales. So be aware that a calculated field, we used to call them measures, and I should correct myself. They're now called calculated fields from this release onwards. You cannot have the same name of a calculated field as a name of a column in a table. All right? So therefore, I've named it sales. And for this one here, I'll name this expense. And let me format both of these as whole numbers, comma separated. Profit can now be calculated. So a new calculated field, profit, is simply sales subtract expenses. And then the ratio of profit over sales gives me a profitability metric. Profit divided by sales. And I'll format this as a percentage. Now, because we're monitoring profitability, and our rule is this, that if profitability drops beneath 5%, that's critical. We're not covering our fixed costs anymore. If it's 10% or above, we're on track. And we can define this directly in the data model as a key performance indicator. So it's an absolute value. It's just evaluating based on the value of the measure itself. And then I specify that 0.05 is the lower threshold, and red represents critical off track, and 0.1 or above is on target, the green. So note here you can play around with this. You can have a centered KPI. You can have that better is worse, or, lower is worse, or higher is worse. So you can play around with the directions, and you can also select the icon style that will be used by reporting applications. And now this measure includes additional metrics of goal and status that can be used in your reporting. So switching back to diagram view, what I've done is extended the sales table by including these calculated fields and the KPI. I can now go ahead and hide the columns to ensure that the sales table only expresses and makes available these calculations. I can also go and hide this entire table because its purpose was simply to allow costs to flow through to this calculated column to be surfaced by this calculated field. And that is the optimization of the model. The last step here, especially if I had multiple subject areas, maybe to come to the Advanced tab and to define a perspective. For example, this would be the monitoring perspective, that if someone wanted to just monitor the profitability, then what they would like is the calendar hierarchy. They may need the products hierarchy. And from sales, they may need access to the sales and the profitability measures. And let's give them the states hierarchy as well. So to demonstrate the new capability of filtering the Power Pivot window by a perspective, these are the tables and their fields that will be expressed in that perspective. We had that in the prior release. What we didn't have in grid view is that this table contains calculated fields, but it can't display them. That's odd. What it should be showing me, it's just the tables. I'm selecting the sales table. I think the problem may have been that I may have had something selected that it didn't like. Let's just select this and try it again. No, there's something a little buggy there. I've not noticed that one before. But what it's supposed to do is just show you what's visible in the perspective itself. That is the optimization or the enrichment of the data model. The next phase, if you intend to use PowerView, is to enrich it and optimize it even further to exploit the capabilities of PowerView. Okay, so this is the starting point for me, is I ensure, whether it's PowerView or not, that the table names are friendly and the column names and calculated fields are friendly as well. For example, state code here. I know this might seem a little pedantic, but I like to put a space in there. The reason being, especially in PowerView, is that when you use that field in the report, you cannot override the automatic labeling that it has. And if you want that report to look professional and slick, now is the time, here in the model. And do it now, not later. You break reports if you rename things like this that are already built on your data model. So we also have kit type here. I might go ahead and do that. The next one is that you can also supplement tables, columns, calculated fields, and KPIs with descriptions. And the descriptions will surface as tooltips in the Power View field list. So for example, for product, and you can't do this in diagram view, but in the grid view, you can right-click the tab and add a description like products defined by marketing. So in case you had different categorizations or descriptions or names for products, it's clear when someone hovers over that field that this is where the products come from. Now, in the prior releases, there was a problem in Power View that the Power View field list would not express hierarchies, it would not express key performance indicators. This was frustrating, especially if you did something like this. You said, because I have a hierarchy with those 4 levels, I will hide the columns. If you did that, you would have nothing visible in Power View. And this is the balancing act you have when optimizing for Power View, is that because a tabular model can be queried with MDX, then existing cube tools can be used, like pivot tables. But if you optimize for Power View, in some situations you're going to de-optimize for the cube tools. So I used to hide the columns that were used as levels of hierarchies, but then Power View wouldn't show anything. And then if you made them visible, then you'd have both the levels of a hierarchy and visible columns that looked like attribute hierarchies, visible in a pivot table, for example. So the great news is, now that hierarchies are exposed, I can keep all of these hidden. But what I may choose to do is actually unhide that date column, because I know that some people want to exploit that new capability of a timeline. And if you do not have a visible field in your model of type date, then the timeline cannot be introduced. Likewise for state, and the fact that this KPI will be visible, profitability, is great, and I'll demonstrate that shortly. Now, the next optimizations have to do with the reporting properties that are available on the Advanced tab. So, the fact is that at Tailspin Toys, we have available on the intranet product images. There are 20 products that we sell, and here I have 20 files. The naming convention is that the ID of the product, formatted with leading zeros to 4 characters, .png, is where those images are found. Now, in tabular model development, you have choice if you want to express images in Power View. If the image is already stored in your data source as binary, then you can import that as a column into your tabular model. But be aware that that could be very, very expensive. And I talked about optimization. If you have numerous products or they're extremely large images, I would suggest that you do not put them in the data model directly. Perhaps one exception would be that if you wanted that workbook to be truly portable, that you may send it to a customer that is not on your intranet and they'll need those images, then yes, it would make sense to put them in there. Otherwise, I would strongly suggest that you externalize the images in a virtual directory like this on a web server, and you can see that if I navigate to any image, there is a URL that will then uniquely retrieve that image. So what I'm going to copy is the leading path to the virtual directory. I'm going to switch across to the Power Pivot window, and in the product table, I will define a calculated column based on that string literal, concatenating by using the format function, the product ID column, using this format code. And then I will concatenate .png. I will rename the column to become just photo. The data categorization is uncategorized, and I can come in here and say this is an image URL. And now Power View will know that the selection of that field, that it will be able to go ahead and retrieve the image from this path. By the way, I think it's a bad practice to hard code these types of paths into your model. Time permitting, and I don't have that time today, I would suggest you add a new table based on some source that's easy for you to update, like a SQL Server table. And what you could do is just import a name-value pair. There's a new DAX function that was introduced in the last release called lookup value. And therefore, what you would do is create an expression that would look up the value from this name-value pair table and build up the path to your product. Should the web server change or that virtual directory be relocated to another server, and it's just a matter of updating a record in a relational table and refreshing that configuration table in your model, and no need to go ahead and modify the definition of the model itself. Okay, before that photo can be used, there's actually another step that has to be taken. So on the product table itself, the next thing I'll demonstrate is the default field set. So the goal of PowerView was to make you as productive as quickly as possible, as few clicks as possible to achieve some amazing things. So an optimization that you can build into your data model is that you can define a default field set that with a single click of a table, the columns and calculated fields that you introduce, for example, like product, category, kit type, and photo. So these fields in this order would appear as a table in the PowerView sheet. That's the default field list. That is optional. The next one is the table behavior. So when you import tabular data, there's no such thing as a primary key defined that says this is the unique identifier for this table. And yet for PowerView, it's important for it to understand where that unique identifier resides. So the row identifier can be configured here in the table behavior, and we know that the product ID is that row identifier. The keep unique rows says, are there other fields in the same table that truly have a one-to-one relationship with that key? So for example, the name of the product and the stock keeping unit and the photograph should keep unique rows. The best way to think about this is if you introduce a matrix, and a matrix allows grouping on the rows. And I said, okay, I'm going to put state and state code, and then I want to look at the sales. The fact is that state code should not be grouped within state. Keep rows unique. Therefore, state and state code would be checked, and when you introduce them in a matrix, it will not group within them. It will keep them on the same row. The last two, the default label, would be what's the default name that should appear when using the table? Well, that would be just the product, and the default image is the photograph. That must be configured in order for the photographs to be surfaced through PowerView. There's one last optimization. And this is perhaps the most challenging of the topics. These calculations that I added in the calculations area, I showed you the first implicit model created what I refer to as an implicit measure by adding a numeric field through the pivot table into the values area. It would actually create a measure for us in the model, but it was implicit. It was implied by its use in a pivot table. Be aware that implicit measures are never surfaced. They're never made visible, so PowerView would never know about them. Explicit is what I've done here. I've said that for sales, explicitly use this calculation to compute sales. They will always be visible unless you hide them from the client tools. But there is an optimization that says if you have a numeric column that is not hidden, then PowerView will surface this as an automatic measure. There's no need for you to actually define it in your model. There is a property here on the Advanced tab that governs the behavior of one of these columns. So default here says it's up to the reporting tool. So for PowerView, if it discovers a numeric field that is set to default, it will say sum. You can explicitly override what the default would be by using any of the 6 aggregate functions supported in the tabular model. Or you can specify that it should never be aggregated. Therefore, do not surface it as an automatic measure. So there is a benefit of this automatic measure for this column against the explicit measure that I had defined earlier. And the benefit is this, that in PowerView, if it's an automatic measure, the user has the ability to switch between the aggregate functions. So it might default to sum, but what they really want to see is average sales. Now, with an explicit measure, that's not possible because it's an explicit calculation that the data model has defined, or the developer has defined in the model. But here is the challenge. If you're building a single data model that will be used by both PowerView and cube tools like a pivot table, and you don't define any explicit measures, the cube tools won't expose any measures. So if you keep them visible to support pivot table analysis, then in PowerView, you're going to have both an automatic and an explicit measure, and that could be confusing. So the truth is, there's no real way to optimize for PowerView and for the OLAP clients, those cube tools, at the same time. So you may well decide it's one or the other, or both, and then education that says, well, you have two measures that do the same thing, but if you use this one, you have the ability to modify aggregate function. So for now, what I'll do is I'll leave this one unhidden. I might just change it summarize by to average, so you see how that works. And we'll see that we have the explicit sales down here as well. And that very much concludes the topic then on how you can optimize and prepare your data model for PowerView. So at this stage, I can switch across to Excel with the full appreciation that I have this connection in the workbook named this workbook data model. And I can build reports based on this, and that is the reporting experience I'll demonstrate now. So creating workbook reports. Workbook reports can be created from the new PowerView sheets and from the pivot table, pivot chart, and cube functions. So we're really going to focus on what is new. Pivot tables and pivot charts really haven't changed, except as I demonstrated with my implicit data model, is that we have a single field list now. No slices are included in the drop zones. So regardless of whether you're reporting off an internal workbook data model or you're reporting off an external tabular or multi-dimensional, you will have the same field list. If you need to add slices, right-click a field. What you do have on the Power Pivot tab is the ability to arrange those slices around the pivot table. That was one of the benefits of the Power Pivot field list in the previous release. So with the focus then on PowerView, PowerView sheets can be added to an Excel 2013 workbook, and they will be based on the workbook data model, or they can be based on an external tabular data model as well. In fact, it's quite possible in the same workbook to have multiple PowerView sheets that connect to different tabular models. One could be internal, the other could be to an external database. The PowerView field list now includes hierarchies and KPIs. And there are additional new features like map visualizations that will require internet connectivity, and you'll end up with the potential to visualize your data geographically. So by the way, to exploit this, there are categorizations. I showed you the auto-categorization for state or province. You can also have numeric columns of longitude and latitude, and you can categorize those, and that way it can then plot on a map according to those explicit coordinates. Internet connectivity is required, and I have to share with you, we're having internet connectivity problems in this room today. So I'll ask you to take a good look at what the map looks like here, and I'm sure that there are many other sessions here this week at the event that will go through the maps, so I won't be able to demonstrate that for you today. Hierarchy navigation is now supported. I can demonstrate that. Color themes and backgrounds, configurable data region font sizes, the ability to add pictures in explicit locations or as backgrounds to the sheets. And let's see this by demonstration. So back to my workbook that's basically an empty spreadsheet at this stage. On the Insert tab, we have the ability to insert PowerView. And here is where it comes to us and says, well, I know you want to do this, but PowerView has not been enabled. And you say, fine, just enable it. And then it inserts a new sheet into the workbook. By default, it will be based on the internal data model for the workbook. So the first report that I will create is profit analysis. And here on the PowerView tab, I can now insert pictures. And I have a logo here in the form of a JPEG. Beautiful. To support interactivity within the sheet itself, here in the PowerView field list, we get to see all of the visible tables. Note that when I hover over product, there is that tooltip that was defined as a description in the model. And now when I expand date, I see that I have the calendar hierarchy, so that is new. And I also have the date field. I would prefer that wasn't there. And we understand that that's there to support timelines in pivot table and pivot chart experiences. I'll introduce just the year level, and what that does by default is creates a single column table. And what's cool about this is I can then configure this to become a slicer, and I'll up the font, so this is new. And so this is now just prompting a user to go ahead and filter by a particular year, or it does support multi-select, or I can reset. Let me set it to 2011. Next, from my state table, I'll introduce from the states hierarchy just the region. And again, I'll up the font, and I'll filter by Pacific Northwest, and I'll reposition down here. Next, from my state, what happens when I bring in an entire hierarchy? Well, the default behavior is you end up with all levels as columns within a table. And then I can introduce from my measures, here defined in the sales table. Let's bring in the number of units. So see this little calculator icon? That's an explicit measure, as opposed to, and I'll bring in sales as well, as opposed to revenue. Now, when I bring in revenue that uses the sigma symbol, that is an automatic measure based on a visible column, that we see that default of average of revenue. Now, see here in the field list that when I look at the drop-down for sales, the best I can do is remove it. Yet an automatic measure allows me to modify to any of the aggregate functions. That is the benefit and optimization of just having visible columns rather than explicit measures. And then finally, we have the KPI, and I can bring in profit, and I can look at the status of that profit. And all is looking very good. So what is new is that we have the ability, when you convert this to a matrix. So let's just look at the Pacific Northwest. I did make it a slicer, thank you. I was wondering why that's not behaving as I expect. Pacific Northwest, thank you. And let's maybe not, that's not what I wanted to do. It has to be a matrix, and where you have multiple levels in the same matrix, you can come here on the Design tab and say, enable drill down one level at a time. So what you'll see now is that I can come to Pacific Northwest, select it, and drill down. All right, so it's always going to be a single column, unlike a pivot table that will expand, collapse by default. The way that drill down works here is that it's always a single column. And my belief for why they've done this is that you haven't got the luxury of moving things around the place like you have in a worksheet. That I could have another pie chart, for example, sitting there, and I don't want it to be obscured by an expanding matrix. To introduce another Power View sheet, on the Power View tab, you can use Power View here. It's exactly the same as coming to the Insert tab and just saying, Insert New Power View Sheet. So here I'm going to create another report that will be I was going to create a map at this point. But without internet connectivity, I really can't. So the best that I can point out at this stage is that when you take a look at the state, see this icon here that looks like a small globe? That's because there's a categorization saying that it's actually of type. It's going to support mapping. So because it's using the Bing Maps, what helps is that you categorize the columns so that they can be fed to the Bing Maps service to help the identification of the coordinates for mapping. The one exception to this is that if you use longitude and latitude, the Bing Maps service isn't required to look up at any point. The best that it's used for is to retrieve the images, and all of the placement of the points on the map is done internally. If you're using names, each name has to be sent up to the service to resolve to long lat, to come back down and then plot it, which is why in some demonstrations or in your own use of this, you might see the dots gradually being added to the map, because one by one the service is translating them into the long lat for you. So I see it as an optimization that if you do have longitude and latitude, have them in the model, because it doesn't need to do that lookup against the service. So I can't demonstrate that for you. But what I then will do with the remaining time is to create a report that will be sales analysis by kit type. So I'm not using Power View anymore. Hey, I didn't show you something. Products and their photographs. If I just click the product table, there's the default field list. Because it's referencing external resources, you must explicitly enable them. And there's the images flowing through. And then we can do great things like tiling. So users can now go ahead and filter by a particular image and name. The reason that I wanted to show you this is because I'm a huge fan of the cube functions, and I noticed that 80% of you hadn't worked with them or perhaps are not aware of them. So what I'm going to do here is introduce a report. In cell B here, when I type in a formula that begins with the words cube, there are actually 7 cube functions natively with Excel. They first appeared in Excel 2007. What they require is a connection to a BI semantic model, be it tabular or multidimensional. I'm going to bring in a cube set, and note the IntelliSense here. It says this workbook data model can be used, and this set is going to go into the state table, to the states, to all. In fact, what I do is say, just give me region.members. This is actually using MDX. And I'm going to say that this set should be captioned with the word region. So really what's sitting here in B2 is a set of members. If I then come into the cell beneath it and say, give me the cube ranked member based on that same connection that is using this set, to give me the first one, I just use the row function, row A1. What row A1 will do is return 1. Row B58 will return 58. So because of this, I can lock in the coordinates to the set here, and then I can copy this down. So the last one, there is no 7th member. They are the 6 regions that were returned by this set. I could then come up here and introduce a cube member from my connection and from product.kittype.all.kit. And so now I have the member for kit stored right there. If I copy this and paste it, the other kit type is RTF. Now, next thing is if I insert a timeline based on my connection. So for the data model, in fact, if I based it off any connection that the data model is using, why isn't it letting me do that? Where is this workbook connection? Data model, there. There it is, and it tells me there is only one field that you could possibly build a timeline off. And I'll drag that here. Now the timeline has a unique name, and we'll see this when I use the cube value function here. So the cube value will extract a value from the model. So what I'm after is from measures, my sales, give me the intersection of this region, comma, this kit type, comma, the timeline underscore date. It has a unique name within the workbook. And there is the value, and I could go ahead, and what I'll do is I'll fix in here, instead of B3, I'm going to say $B3 and C$2. The benefit of this is that I can copy and paste. Let me just format them so they appear. And now we can use the timeline with the cube functions. Show me what happened in 2011. Not exactly sure why that is so slow. At quarter level, what were quarter 2 and quarter 3? So you can pass the timeline into the cube functions. So we've explored Power View. New features for pivot tables. I've covered what's new there for the pivot table field list. So we've lost 2 drop zones, but you really haven't lost functionality. You just right-click a field, insert the timeline, or insert the slicer. New features of the timeline allow filtering by calendar time periods only, must be based on a visible data model column that stores date values. It allows filtering by individual years, quarters, months, or dates, or ranges of those. And like slicers, can be used in pivot tables and cube values. However, timelines don't work in Power View. Final discussion, I'm just about to wrap up, is what happens with your existing investments by using Power Pivot in Excel 2010. So the great news is that there is an upgrade path. What happens is that when you open that XLSX document in Excel 2013, the first attempt to actually use the data model, be it a new report, be it a cube function that's attempting to connect, or any existing report is refreshed, it will then prompt you to upgrade, and it's a one-way process. It'll upgrade the metadata, it will keep the data, and then it will force you to save the workbook. At that point, you can no longer open that in a prior version of Excel. Be aware that I think there's a bug. KPIs will not be imported. You'll have to redefine them. And if you're using the cube functions, you may have noticed now that the connection name for the workbook model is now this workbook data model. You'll have to update all cube functions from what used to be, I think, the Power Pivot model. So, there's a series of demonstrations that bring that all to being. What I haven't demonstrated, because again, I don't have connectivity, is that workbook now, I'd like to show you this, is that when I save this, and we look at the information, that the workbook consisting of a data model and data comes to less than 1 megabyte. You might think, hold on a minute, my implicit model was 50 megabytes. The difference is that when I filtered out the order column, that was extremely expensive when it came to compressing and storing that text data. So I think that the explicit approach rocks simply because you have the ability to optimize by not bringing in unnecessary data. So here we see my demonstration based on 3.25 million sales rows of data comes to less than a megabyte for metadata, model, and accompanying reports. If I chose to publish this to SharePoint, I could secure it, I could configure auto data refresh, and my IT team could keep an eye on what's going on with usage and resource utilization. So where do you go from here? In summary, you take away with you today that Excel 2013 truly rocks when it comes to providing for those business analysts the ability to create data models and to report from them in the same workbook, implicitly or explicitly. Power View sheets are now supported in the workbook, and numerous new features are surfaced through Power Pivot and Power View. I leave you with a number of resources that could be helpful in exploring this further, but otherwise, I thank you very much for your time and attendance. Very important to us is the evaluation and the chance for you to win some great prizes. We would love to hear back from you about what you think of this session. Please take the time and put the effort into evaluating this session. We look forward to your feedback. Thanks again very much for attending this session.